Hello and welcome back. We're going to continue our wonderful discussion of areas between two curves and some talk about some cross sections as well in another exciting adventure of Mr. Wernau Does Your Homework. Alright, for question 1, we're asked to find the area between the line y equals 2x and the parabola y equals x squared. So they give us the graph right over here. Forgive my graph, it's not to scale there. And what we're asked to do is we want to find, for question A, we're asked to find the area of the region bounded by the two. So of course our area is going to be bounded by this little shaded region right in here. Looks kind of like a pea pod. So since I'm looking for area, well, the first thing I'm going to do is draw out our rectangle of mathematics. And I'm going to go ahead and do that here. My rectangle is going to be vertical. Since I am in terms of x, I'm going to make a vertical rectangle. So it's a vertical rectangle. And again, the reason for that is because we are in terms of x. And when I draw my rectangle of mathematics, remember the skinny part is, of course, here on the bottom down here. There's two ways to look at it. One, that's just my change. It's going to hit the x-axis, so that's my change in x. But another way to remember it is, since we are in terms of x, the skinny part has to be very skinny. And remember, we said we call this dx. Remember, dx is that change in x as it goes to 0. So as dx goes to 0, this gets really skinny. So the skinny part is always what we're in terms of. To get the height of our rectangle, remember, we're going to go the top function minus the bottom function. And our top function is the line, so it's going to be 2x minus x squared. And now we can go ahead and find our area. I'm going to use my rectangle of mathematics to get the area between these two graphs. And the area will be, what's that? Length times width, so it's going to be our 2x minus x squared dx. Now that's the area for one rectangle, but remember, this rectangle is going to move right and left, because we go in terms of x, right and left between 0 and it looks like 2 where they meet. So you got to imagine this rectangle kind of sweeping out an area right there. And if I evaluate that integral, whoops, there we go, from 0 to 2, I can evaluate this. This just becomes x squared minus x cubed over 3, and we're going to evaluate that from 0 to 2. Using our fundamental theorem, that's going to become 4 minus, this becomes 8/3 minus 0. And of course, you can leave your answer like that. You can simplify that if you want to. Alright, so the next one we're going to take a look at, of course, is part B. Now, part B is a little bit different. For part B, they want us to find the cross sections. And here it is right here. It says, part B, we're looking for the region R has a base of a solid. For this solid, each cross section perpendicular, this is nice, to the x-axis has an area of sine of pi over 2x. Find the volume. Well, we might remember for cross sections, we said the volume was the area of the base times the height. And the height in our secret language was always the dx or dy. It's always the thickness of our cross section. And we're luck here, because they told us B, big B, the area of the base of our cross section, so this would be like the base of my cross section, is going to be the function, whoops, hello, don't know what happened there, sine of pi over 2x. So if I want to get my volume here, my volume is just going to be the area of the base, which they tell me is sine of pi over 2x times the height, the thickness of it, dx. And we will evaluate this again from 0 to 2. So this one's not very pretty for us, so we are going to have to use u substitution. So my u is going to be the pi over 2x. My du would be pi over 2 dx, giving me dx is 2 over pi du. And I can evaluate that a little quickly now. My volume is then going to be, I can factor out my constant, that's at 2 over pi. The antiderivative of sine is negative cosine, so we're going to get negative and then get cosine of pi over 2x. That's our shortcut from 0 to 2. Evaluating our integral, this negative 2 over pi is a constant, so I'm going to go and leave that outside. Plug in the 2, right? If I plug in 2, that becomes cosine of pi, which is negative 1, minus f of 0, that becomes cosine of 0, which is 1. And you can leave your answer like this, but if you want to be fancy, you would just get 4 over pi right there, and that would be the volume of that cross section. Now remember, you can't really tell what this looks like. I mean, at least I can. But imagine like the base being this function right here, and this is what the volume from 0 to 2 would be. Part C for this question, let's take a look here. It says another solid has the same base R. So another solid has our base up here between the two curves. So for part C, it says for this solid, the cross sections perpendicular to the y-axis are squared. Now be careful, it does say y-axis, so we do have to change our variables here. Right, but do not evaluate, our best friend in mathematics, do not evaluate an integral expression to find the volume of the solid. So for this one, if I'm going to look at my region again, so I'm going to go ahead and draw it out again. It looks like this. Whoops, there we go. There is my region R, but this time we want to be perpendicular to the y-axis. So when I look at my rectangle of mathematics, this time it's going to be horizontal. Because we are perpendicular to the y-axis, we want a horizontal rectangle. Now, since we want a horizontal rectangle, this automatically tells us we need to be in terms of y. So I need to put my answer here in terms of y. So when I look at my horizontal rectangle of mathematics, my skinny part, that's the part that's going to be in terms of, there's my dy, but this time it's going to be right minus left. Remember, do right minus left because I want to find this length right here. And if I knew this x value and this x value, I can find that length by just subtracting the two. Alright, so we gotta get the right function and the left function, but you gotta be careful. Right now, our equations are in terms of x. We have to get these in terms of y. So I just need to solve x is equal to, what's that, y over 2. Here we're going to get x equals plus or minus root y, but since we're in the first quadrant, we're just going to take the positive. So now I look, what's on the right side? Oh, that's my square root. So that's my square root of y minus the left, which is y over 2. Okay, so now that we have that, okay, now we're ready to start setting up our equation. Now they do tell us, if we look here, our cross sections this time are squares. So the cross sections are squares. So in other words, what we're doing is we're imagining this being the bottom here, and it's a bunch of squares. There'd be a square here coming out, a square here coming out, and it'd almost be like kind of like almost like a banana, I guess, looking like, you know. So we have all these little squares. So I'm going to draw a square. There's the base of my square. Now the base of the square is our rectangle of mathematics. So the base of that square is the square root of y minus y over 2. Now because it's a square, it'll also have a height of y minus root y minus y over 2. And then to get our volume, now remember it does have a thickness here, right, dy. Remember, because this base right here, this right here is our bottom right now. So it does have a little thickness, dy. So to get our volume, remember it's the area of the base times that height. Remember a little secret, that's just going to be the dy here. So to get my volume, it's going to be the area of the base. Well, it is a square, so we know how to get the area of a square. The square root of the side squared dy, the area of the base, times my dy, and I'm going to evaluate that from, well, be careful, we have to in terms of y. Remember, for part A, we went from 0 to 2, x. But we're in terms of y, so we have to use our y coordinates. So remember this met at 0, oops, sorry, not 0, it's at 2, 4. So I need to go for my y. So my y is going to go from 0 all the way to 4 right there. All right, so that's number 1 right there for you. And remember, we did not have to solve it, so we just leave it alone. Go on to my next video, and we'll do another example. Thanks. See you soon. Bye.